In this video, we're going to be taking a look at Math 7 Unit 1, Lesson B, square roots. So let's start with these four boxes up here, or the squares. How do you find the area of each figure below? Well, what you could do, you could count each square you see. So I could count 1, 2, 3, 4. So the area would be 4. For the second square, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So area would be 9. Now, we could do the same thing for these other two, but as these squares get bigger and more boxes to count, a lot of times we want to know a shortcut way to do that. Well, if we look at the first square and I count the length here, there are 2 boxes across the length. There are 2 boxes here, and so to find area, I would do 2 times 2, which is 4. However, keep in mind, we just did the lesson over exponents. 2 times 2 is really 2 squared. So that is an exponent. We squared the 2 and we got 4. Same thing for the next square. The length is 1, 2, 3. The height or the width is 3. So to find that area, I could have just done 3 times 3. Keep in mind that is 3 squared, and 3 squared is 9. Now, the reason why I wanted to show you those shortcuts is because with the next square, I don't want to have to count all of those squares. So I'm just going to count the length, 1, 2, 3, 4. So the length is 4. The width is also 4. So it's a square, both sides are the same. So area would be 4 times 4. Keep in mind that is 4 squared, or 16. And for the last square, we have 1, 2, 3, 4, 5. And 5. Now, many of you already know area would be 5 times 5, or 5 squared, which is 25. Now, we can find 25 faster than counting all 25 boxes. So again, exponents will be very helpful in this situation. And we're going to use these exponents then to learn about square roots. So in the middle of your paper, you will also see the vocab that I wrote out to save you some time. One of the key vocab words, inverse operations, remember those are operations that undo each other. So an operation that undoes another one, or undoes another, whichever way you want to say that. For example, subtraction is the inverse to addition, and those are opposite operations. The other vocab, the radical symbol, looks like a division sign with a check mark. So just keep that in mind. Now, I do want to point out one thing in the vocab, and I'd like for you to write this in. These 2 vocab words are inverse operations. Inverse operations. So when we have a perfect square and a square root, those are going to be opposite operations, similarly to subtraction and addition. So let me show you a little bit about that. So let's just look at these 4 problems here, and in the next video we'll go on to the next page. So 3 squared is just the same as 3 times 3. So like the squares we were doing above. And that answer is 9. So I am squaring the 3. 3 squared is 9. The inverse operation, now when I put that little check mark or the square root symbol, the radical sign, I'm now asking, what is the square root of 9? So the question is, what number times itself will give me 9? Times itself is 9. Now we don't have to write that out every time, but this is what I'm thinking when I see that symbol. Well, the number that multiplied by itself to get 9 was 3. So 3 squared is 9. The square root of 9 is 3. So what you're doing, the answer to the square root, was the base when I squared it. Okay? So let's look at one more. 5 squared is 5 times 5, which is 25. The square root of 25 is 5. Again, the answer to the square root is the base, or the number that I was squaring.